Hello, my name is Matthew Bayliss at the University of Liverpool, and I'm talking about the impacts of climate change in the UK on our health and well-being. I'll start by showing some of the ways in which climate and weather impacts on our mortality from a variety of causes. The numbers here are estimates of the average annual mortality from those different causes. I also have shown climate-sensitive infectious diseases. That is, those diseases which infectious diseases which are sensitive to the effects of climate. And although there aren't precise estimates of the mortality from those, we know it lies in the several millions. My group has done a lot of work looking into this impact in more detail, in particular asking how many infectious diseases are sensitive to climate, in what ways does climate affect them, and what are the characteristics of these climate-sensitive diseases. Through the Enhance project, we screened a very large number of papers on about 150 important and high-impact diseases of people and animals, searching for links between certain climate drivers and different measures of disease. And we found that about two-thirds, or nearly two-thirds, of these important infectious diseases have evidence of sensitivity to climate. The most frequently recorded climate drivers are temperature, rainfall, and humidity, although there were several others often reported. For some diseases, these relationships between the disease and climate are very complex, and with some diseases being affected by multiple drivers, up to 9, that's the maximum we detected. The diseases which are most commonly climate sensitive tend to be those which are vector-borne, that is transmitted by insects or ticks, for example, or those which are foodborne and waterborne. And finally, we found that zoonotic diseases, that is those which we catch or caught in the past from animals, tend to be more climate sensitive than non-zoonotic diseases. So vector-borne diseases are highly climate sensitive. So let's start by talking about those. Of vector-borne diseases, by far the most important globally is malaria, which still kills about 500,000 people every year. There's different types of malaria. The most lethal is known as falciparum malaria, and this has a high temperature requirement. And most modelling of the suitability of the UK for falciparum malaria find that that risk is essentially zero, even under extreme emission scenarios and going up to the end of this century. So I think we can effectively discount any risk of sustained transmission of falciparum malaria. But there are other types of malaria, including Vivax malaria, which has a lower temperature requirements and which used to occur in Europe. And importantly, the UK still harbours populations of the mosquitoes which can transmit Vivax malaria. That's the Anopheline mosquitoes. We find them particularly in the south and the east of England. So should we be worried about Vivax malaria coming to the UK? Well, in fact, we used to have Vivax malaria in the UK. Here I'm showing you some quotes from Chaucer and Shakespeare, both of them referencing tertian fever and ague as an old name for malaria. So we used to have malaria in the UK. And in fact, it's not something of the distant past. The last known transmission of malaria in the UK, from one person to another in the UK was as recent as 1950. So should we be worried about Vivax malaria in the future? Well, I don't think so, because the reason that we don't have it anymore is to do with improved housing, changes to land use and so on, which has suppressed the populations of mosquitoes and got the disease under control to an extent where it's not a threat anymore, and I don't think will be in the future. But perhaps where we should have greater concern is over mosquito-borne viruses or arboviruses. And some examples of arboviruses transmitted by Edine mosquitoes are yellow fever, dengue, chikungunya, and Zika. And these are transmitted by a species known as the Asian tiger mosquito, that beautiful specimen on the right there, which has already invaded Europe. And my group's done some work modelling the suitability of the UK for this species under 2 climate change scenarios here, ICP 4.5, 2 emission scenarios, 4.5 and 8.5. And looking up to the 2060s, so 40 years ahead, we find that much of southern England will become suitable for this mosquito by that time under both emission scenarios. So we predict that the UK will become increasingly suitable for this mosquito. And importantly, this mosquito is traveling, is spreading quite rapidly through Europe. This shows its known distribution 10 years ago and just last year, with the red areas where there are settled populations of this mosquito. As you can see, it's moving north quite rapidly. And very importantly, in the last 3 or 4 years, we've begun to find specimens of this mosquito in England, and in particular in the southeast in Kent. So it looks as though it is beginning to invade already. So with this mosquito entering the UK, and we believe being able to spread further in the UK, particularly with climate change, should we be worried about the diseases that it transmits, or is able to transmit? So we've looked at this in some detail for the arbovirus that causes Zika disease. And here we've found that even though we think the mosquito will be able to occur over much of southern England, the temperature requirements for transmission of viruses, such as Zika virus, are such that we think that the risk of transmission in the future is low. And it may well be that we get populations of the mosquito that, at least for some time, are unable to transmit the virus. So here it's not until the 2080s under RCP6 that we begin to see southern England becoming slightly suitable for transmission of a disease like Zika. Let's consider also food animals and the threats to them from vector-borne diseases. This is a disease called blue tongue, which is a viral disease spread by biting midges. And this is a disease that emerged in Europe about 20 years ago, spreading from Africa, and has become endemic in much of Europe, and in 1 year did it occur in the UK. Considering emission scenarios 4.5 and 8.5, we find that the risk of this disease occurring in the UK increases up to the end of the century, and not just the risk of disease outbreaks, but also the scale of the outbreaks when we get them. We forecast that those disease outbreaks will be larger, with more farms and more animals threatened. But can we do, an important question is whether we can do something about that. And so with animal disease, I used to think this was only animal disease, they can be controlled by restricting movements, with farmers told that they can't move their animals from farm to farm any longer. And here we've looked at the bottom, the potential spread of this, or the risk to farms from this disease if there are no restrictions to movements. And as you can see in that situation, comparing the current on the left to the future projection on the right under a high emission scenario, we see much greater risk of disease like blue tongue in the 2080s under a high emission scenario. But if we allow for controls to be imposed, the sort of controls that we would use now to deal with blue tongue, we find that's very effective at stopping this spread, even in the 2080s. So we concluded here that even under a high emissions scenario, our current control measures appear to be able to keep blue tongue in check. I think this is an important point to make, that even though the risk of diseases might increase in the future under climate change, it may be that we still have the means to control them. Let me finish by talking about pandemics, and in particular, pandemics like the current one of a respiratory disease. My group has done some work looking for links between the current COVID-19 outbreak and climate, and we've struggled really to find a relationship. We find some slight effect of daylight hours and also a hint of a relationship with temperature. But by and large, there's little or no evidence for a link between COVID-19 and climate, suggesting that actually the impacts of climate change in the future may not be great. So that may not be something that we should be worrying about in terms of respiratory diseases. But we should be extremely concerned, I believe, about the increasingly clear link between environmental disturbance and disease emergence, Environmental disturbance meaning destruction of forest, harvesting of wildlife, building roads into rainforests and so on. And the indirect effects of climate change on how we interact with the environment or the environment itself. So as we go into the future, we will, it's expected that we will continue to disturb environments, and climate change will affect environments directly and also indirectly through our behaviours. And by affecting the way we interact with the environment, so it may trigger further emergences of new diseases. So of the diseases that that affect humans, about 2/3 are believed to have had an animal origin, and at some point they jumped species into us. Now, most of these diseases have come from livestock, but there are others that have come from domestic animals or pets, or from wildlife. And I think wildlife in particular present an enormous untapped pool of new pathogens, many of which we don't even know exist. And some of them will have epidemic or pandemic potential. So while most of our known pathogens, most known human pathogens from animals have come from perhaps 20 livestock animals or pets, there are thousands of wildlife species, each with their own unique virus assemblages, which potentially could spill over into the human population. Consider that just in the last 20 years, we've had perhaps 7 close brushes with pandemics originating from animals, and then finally SARS-CoV-2, which has turned into that pandemic. So I've listed here SARS, H5N1 avian flu, H1N1 swine flu, Middle Eastern respiratory syndrome, Ebola, Zika, and then SARS-CoV-2, all of which had an animal origin, and those shown in red had a wildlife origin. So for me, COVID-19 and the huge impact that it's had and that it's continuing to have globally shows that the extensive exploitation of and damage to our natural environment through climate change and through direct human activity simply cannot be tolerated anymore. I'd like to thank you for listening to my presentation, and I've included some references to the pieces of work that I've talked about. Thank you very much.